Video we're going to be looking at how we fill in probability trees, which is usually a 2-marker, and it's dead easy. If you're told that, for example, the chance of you winning a game was 0.7, then the other branch of the tree has to add up to 1. So losing would be 1 minus 0.7, or what do you add to 0.7 to get to 1? That would be 0.3. And most of the time, the second game, in this case, so we're playing 2 games, will be exactly the same probability. If they don't mention anything, then you just go ahead and fill in this to match the probabilities from the first game. Okay, that happens most of the time. On occasion, it will say in the question, if you win the first game, then the chance of you winning might change. Let's say it goes up to 0.8 because you're more confident and you're on a roll or something like that. Then our loss would have to change to 0.2 to keep it adding up to 1. And if you lose your first game, the chance of you winning might drop to, say, 65%, 0.65. And so your losing probability would go up slightly. So 1 minus 0.65 is 0.35. That does happen sometimes, but quite rarely. The probability on this side is usually the same at the lower levels. Okay, as we progress, we'll see that they often change, but for these ones, they're usually the same. And then they'll ask you to use this tree for the part B, so another couple of marks, 2 or 3 marks. What's the chance of you winning both games? Okay, what's the chance of you winning both games? So we're essentially going along the branches like this, win, and then win. So that would be 0.7 for the first game and 0.8 for the second game. They're the 2 numbers that we need. And students often make a mistake here and try to add these. But if you do that, our answer would be 1.5, which is more than 1, which is not possible with probabilities. So we need to multiply as we go along the branches. Okay, 0.7 times 0.8 is 0.56, 56% chance of winning both your games. So let's try losing both games as another example. 0.3 times 0.35. Okay, put that in your calculator. That will be your chances of losing both your games. So 0.3 times 0.35, 0.105, like that. So about 10% chance of losing both your games.